using prepared statements. In the event that you need to execute a particular query multiple times with different values, for example, a series of insert statements, the MySQL database server supports prepared statements, which offer a more efficient means of accomplishing this task than repeatedly calling the MySQLi query method. Essentially, a prepared statement is an SQL query template containing placeholder variables for the values to be inserted or modified. The statement is stored on the database server and invoked as often as needed, with the placeholders replaced with actual values on each execution. Because the statement is stored on the database server, a prepared statement is typically faster for batch operations that involve running the same SQL query over and over with different values. Question: how do we prepare statements of a better performance? The normal course: every time an SQL statement is executed on the database server, the server must pass the SQL code and check its syntax and structure before allowing it to execute. With the prepared statement, the SQL statement is stored in a temporary location on the database server, thus only needs to be passed and validated once. Further, every time the statement is executed, only the placeholder values need to be transmitted to the server instead of the complete statement. To use a prepared statement, it is necessary to first define the SQL query string that will be executed multiple times. This query string typically contains one or more placeholders denoted by question marks. These placeholders will be replaced by actual values on each execution of the statement. The query string with its placeholders is then passed to the MySQLi object's prepare method, which checks the SQL for errors and returns a MySQLi stempty object representing the prepare statement. Executing the prepare statement is now a matter of performing two actions usually within a loop. First action: bind the values to the prepare statement. The values to be interpolated into the statement must be bound to their placeholders with the MySQLi stempty object's bind param method. The second action: execute the prepare statement. Once the values have been bound to their placeholders, the prepare statement is executed by calling MySQLi's stempty object's execute method. This method replaces the placeholders in the prepared statement with actual values and execute it on the server. Handling errors. If your database code doesn't work as expected, don't worry. The MySQL extension comes with a bunch of functions that can tell you why. The MySQLi object's error property holds the last error message generated by the database server. The MySQLi object's error number property holds the last error code returned by the database server. The MySQLi connect error function returns the error message generated by the last connection attempt. The MySQLi connects error number function returns the error code generated by the last connection attempt. Introduction to SQLite. SQLite is a fast, efficient database system that offers a viable alternative to MySQL especially for small to medium-sized applications. However, unlike MySQL, which contains a large number of interrelated components, SQLite is fully self-contained in a single library file. It's also significantly smaller in size than MySQL. The command line version of SQLite weighs in at under 200 kilobytes and supports all the standard SQL commands you are used to. MySQL and SQLite also differ in their license policies. Unlike MySQL, SQLite source code is completely public domain, which means that developers can use and distribute it however they choose in both commercial and non-commercial products. SQLite's small size believes its capabilities, however, it supports databases up to 2 terabyte in size and can actually produce better performance than MySQL in certain situations. Part of this is for architectural reasons. SQLite reads and writes records directly from and to database file on disk and so incurs less performance overhead than MySQL, which operates a client-server architecture that may be affected by network level variables. Unlike MySQL, which offers a wide range of different data types for its fields, SQLite supports just 4 types. Integer, a numeric type for signed integer values. Real, a numeric type for floating point values. Text, a string type. Blob, a binary type. What is more important, SQLite is a typeless database engine. This means that fields in an SQLite database need not be associated with a specific type. And even if they are, they can still hold values of a type different than what is specified. The only exception to this rule are fields of type integer primary key. These fields are auto-number fields that generate unique number for records in a table, similar to MySQL's auto-increment fields.